Good morning, student. Today we are going to discuss about the another chapter of the classification of the elements, that is the periodicity and periodic properties. Chemistry first year English medium. Today we are going to discuss about the periodicity and periodic property. What is periodicity? Variation in period and group. Write the periodic properties. Ask the question. Here is today we are going to discuss about the periodicity and periodic properties. What is periodicity? The repetition of the certain properties of the elements. The repetition of the certain properties of the elements at regular intervals. At regular intervals, one by one. That is, the elements are arranged. The elements are arranged at the increasing order of their atomic number. So that is the first one. Hydrogen, helium, lithium, beryllium, boron up to here is the neon. That is also known as the elements are arranged increasing order of their electron configuration. So that is also known as the repetition of the certain properties of the elements. The repetition of certain properties of the elements at regular intervals, one by one. This repetition of the certain properties of the elements at regular intervals in the periodic table is called periodicity, and their properties also called as a periodic properties. Periodic properties. The repetition of the certain properties of the elements at regular intervals in the periodic table is called periodicity, and their properties also called as a periodic properties. Periodic properties. Once again, the repetition of the certain properties of the elements at regular intervals one by one, that is also known as a regular intervals in the periodic table is called periodicity, and their properties also called as a periodic properties. The repetition of certain properties of the elements at regular intervals in the periodic table is called periodicity, and their properties also called as periodic properties. Periodic properties, that is the periodicity means that the repetition of the certain properties of the elements at regular intervals in the periodic table is called periodicity, and their properties also called as periodic properties. Periodic properties. Once again, the elements are arranged. That is also known as the increasing order of their electron configuration. That is also known as a repetition of the one by one. One by one. That is also known as a repetition of the certain properties of the elements at regular intervals in the periodic table is called periodicity, and their properties also called as periodic properties. Periodic properties. That is the periodic properties are first one, atomic radius. What is periodic properties? That is the first one is the periodic properties. That is the first one, atomic radius, and second one ionic radius, third one inert radius, and fourth one ionization potential or ionization enthalpy. That is also called as the IP or IE. IP or IE. IP also called as the ionization potential. IE also called as the ionization enthalpy. Remaining electron affinity. Electron affinity. Next one, electropositivity and electronegativity. That is the periodic properties. That is the first one is the atomic radius, second one inert radius, and third one inert radius, fourth one electron affinity, fifth one ionization potential. Ionization potential, ionization enthalpy. Next one electropositivity and electronegativity. That is the periodic properties. First one is the periodic properties. The first one is the atomic radius. What is atomic radius? Here is the any atom consists of the center of the nucleus. The distance between the center of the nucleus to the outermost electron and atom is called atomic radius. Here is the one atom. Atom consists of the center of the nucleus. The outermost exists the electron. The distance between the center of nucleus to the outermost electron and atom is called atomic radius. Atomic radius. The distance between the center of the nucleus to the outermost electron and atom is called atomic radius. The distance between the center of nucleus to the outermost electron and atom is called atomic radius. The atomic radius units angstroms, picometers, nanometers. That is the units of atomic radius. Angstroms, picometers, nanometers also called as the units of the atomic radius. Next, another point, the atomic radius is divided into 3 types. How many types are the atomic radius? 3 types. That is the based upon their bonding nature. The atomic radius is divided into 3 types based upon their bonding nature. That is the first one, metallic radius. First one is the metallic radius or crystal radius. Metallic or crystal radius. And second one is the covalent radius. And third one is the van der Waals radius. That is the atomic radius is divided into 3 types based upon their bonding nature. Those are first one, metallic radius. And the second one, covalent radius. And the third one, van der Waals radius. That is the atomic radius is divided into 3 types based upon their bonding nature. Those are first one, here is the metallic nature. Metallic nature or crystal radius. And the second one is the covalent radius. And the third one is the van der Waals radius. That is the atomic radius is can be divided into 3 types. Once again, atomic radius. It is indicated by the R, small r. It is R also called as the atomic radius. What is atomic radius? The distance between the center of the nucleus to the outermost electron and atom is called atomic radius. The distance between the center of nucleus to the outermost electron and atom is called atomic radius. The units of the atomic radius is angstroms, nanometers and picometers, pm. Pm also known as a picometer, Nm also known as a nanometers. Here is the A is the angstroms. The atomic radius can be divided into 3 types based upon the bonding nature. Those are first one, metal radius or crystal radius. And the second one is the covalent radius. And the third one is the van der Waals radius. That is the atomic radius can be divided into 3 types based upon their bonding nature. Those are first one, metal or crystal radius, and the second one is the covalent radius, and the third one is the van der Waals radius. Remaining next one, the metallic radius. Metallic radius or crystal radius. Here is the metallic radius means that the half of the distance between the nuclei of 2 adjacent metal atoms. Half of the distance between the nuclei of 2 adjacent metal atoms bonded with the metal bonds. Bonded with the metal bonds is called metallic radius. Here is the metallic radius means that the half of the distance. Here is the one atom, next one is the one atom. Here is the half of, next one is the half of. Half of the distance between the nuclei of 2 adjacent metal atoms bonded with the metal bonds. Bonded with the metal bonds is called metallic radius. Metallic radius means that the half of the distance. Here is the half, next one is the half. Half of the distance between the nuclei of 2 adjacent metal atom bonded with the metal bonds is called metallic radius. Here is the one half, next one is the another half. Half of the distance between the nuclei of 2 adjacent, 1 and 2, 2 adjacent metal atoms bonded with the metal bonds or crystal bonds is called metallic radius. Example, the inner nuclear distance. Here is the inner nuclear distance between the 2 adjacent sodium atoms is 3.72 angstroms. So, one atom of the atomic radius, metal radius of sodium equal to the 1.86. That is the atomic radius or metallic radius of, here is the sodium, 3.72 by 2 is equal to 1.86. That is the inner nuclear distance between the 2 adjacent sodium atoms. Sodium atoms 3.72 angstroms. So, however, the metallic radius of sodium equal to the 1.86 angstroms. That is also known as a metallic radius or crystal radius. Once again, half of the distance between the nuclei of 2 adjacent metal atoms is bonded with the metal bonds or crystal bonds is called metallic radius. The inner nuclear distance between the two adjacent sodium atoms is 3.72 angstroms. So one sodium atom of the metal radius is 3.72 by 2 is equal to 1.86 angstroms. Remaining second one, covalent radius. What is covalent radius? Here is the half remaining. Half of the distance between the nuclei of two adjacent atoms bonded with the covalent bond. Remaining here is the metal bonded with the metal bonds or crystal bond. But here is the covalent bond. Half of the distance between the nuclei of two adjacent atoms bonded with the covalent bond is called covalent radius. Covalent radius means that half of the distance between the nuclei of two adjacent nuclei of two adjacent atoms bonded with the covalent bond is called covalent radius. Half of the distance between the nuclei of two adjacent atoms bonded with the covalent bond, that is also strong bond. Covalent bond is called covalent radius. Here is the inner nuclear distance between the two adjacent chlorine atom. Two adjacent chlorine atom consists the 1.98 angstroms. So one chlorine atom of the covalent radius is 1.9 by 2 is equal to 0.99 angstroms. Once again, here is the inner nuclear distance between the two adjacent chlorine atom. Here is the one chlorine, next another one chlorine. Two chlorine atoms consist the 1.98 angstroms. So one chlorine atom covalent radius is 1.92 by 2 is equal to 0.99 angstrom. That is also known as a covalent radius example. Next another one. Here is the example. Half of the distance between the nuclei of two adjacent atoms bonded with the covalent bonds is called covalent radius. Example, the inner nuclear distance between the two chlorine atoms consists the 1.98 angstroms. So, one chlorine atom of the covalent radius is equal to 1.98 by 2 is equal to 0.99 angstroms. Next one, third one, van der Waals radius. First one is the metal or crystal radius, and second one is the covalent radius, and third one is the van der Waals radius. Here is the half of the distance between the two adjacent molecule. But here is the two adjacent atoms. But here is the molecule. Half of the distance between the two adjacent molecule held by the another two different molecule. Here is the two adjacent molecule of two another different molecule is held by the van der Waals forces is called van der Waals radius. Once again, half of the distance, here is the half, next one is the half. Half of the distance between the two adjacent molecule. Here is the one chlorine molecule, next another chlorine molecule. Half of the distance between the two adjacent molecule of two another different molecule held by the van der Waals forces is called van der Waals radius. Example, the inner nuclear distance between the two adjacent chlorine molecule consists the 3.6 angstroms. So one chlorine molecule covalent radius is 3.6 by 2 is equal to 1.8 angstroms. That is the van der Waals radius. Once again, half of the distance between the nuclei of two adjacent molecule of two another different molecule held by the van der Waals forces is called van der Waals radius. Example, the inner nuclear distance between the two adjacent chlorine molecule. Two adjacent chlorine molecule consists the 3.6 angstroms. So one chlorine molecule van der Waals radius is 3.6 by 2 is equal to 1.8 angstroms. That is the different atomic radius. Here is the atomic radius. The distance between the center of the nucleus to the outermost electron atom is called atomic radius. The atomic radius can be divided into three types based upon the bonding nature. That is the metal bonds or crystal radius. Second one is the covalent radius. Third one is the van der Waals radius. That is the type of atomic radius. That is the example of the different metals and different atoms are exist the metal radius and covalent radius. Third one is the van der Waals radius.